Graph the following semicircle and state the maximal domain and range. So the first thing we can do is identify transformations that have occurred to this graph. So the first thing we can note is that the circle has a radius of 5 units, and that's because we look at this number here and it is 25, and the square root of 25 is 5. Next we can see that the graph has been reflected over the x-axis, and that occurs due to this negative sign just out the front. So now what we need to do is determine the key features of this graph. So the first thing we can do is find the y-intercept, and that is found when we let x equal 0. So if we sub that in, we will have y is equal to the negative square root, and we'll have 25 minus, and wherever there's an x we replace it with a 0, so minus 0 squared. Evaluating that, we will have y equals negative the square root of 25, which just equals negative 5. Next we can find the x-intercepts of this graph by letting y equal 0. So we substitute 0 for y, and that is going to equal negative the square root of 25 minus x squared. And now if this expression on the right hand side is equal to 0, that means the part under the square root sign must be equal to 0. So we can say that 25 minus x squared is equal to 0. And then we can add x squared to both sides of this equation. So we find that 25 is equal to positive x squared. And then if x squared is equal to 25, we can say that x is equal to plus or minus the square root of 25, which just gives plus or minus 5 for the x-intercepts. So now we're ready to graph this. So our graph is going to look something like this. And now we can label all our key features. So we had our x-intercepts, which were at negative 5, 0, and at positive 5, 0. And both those points are included, so we have coloured in dots. And then we also had our y-intercept, which was down here, at x is 0 and y is negative 5. So we also need to state the domain and range of this graph. So the domain is all of the possible x values that this graph can take. So we can see from the graph that that is x is an element of, and the smallest possible x value is over here at negative 5. So negative 5, and we use a square bracket because that value is included. And it goes all the way up to the largest x value, which is at positive 5. So we have negative 5 to 5, both with square brackets. And for the range, which is the y values that are generated by our rule, we find that y is an element of, and the smallest possible y value is down here at negative 5. So we have y is an element of negative 5, and that's included. And then the largest possible y value are up here at 0 and 0. So we have the range is y is an element of negative 5 to 0, and both of those are included, so we have square brackets around both of them. Over on this slide we have a computer generating a more accurate graph of y equals negative square root of 25 minus x squared, and as you can see all the key features are the same as what we found previously, and over here we have the maximal domain and the maximal range for this graph.